Okay, good morning, students. I hope you are well. I hope you have studied the previous lessons because they are very important. So, we will continue our chemistry classes. So, today is lesson number 6 from chapter 6 from page 186. Now, we will start section 3, okay? Ionic bonding and ionic compounds. And there are key terms that we are going to learn. For example, what is an ionic compound? What is a lattice energy? What is a formula unit? What is a polyatomic ion? Okay, but from our previous lessons, you should have some information. Okay, you should have studied. So let's start. So now you know most of the rocks and minerals that make up Earth's crust consist of what? Of positive and negative ions held together but by ionic bonding. So they are saying that the Earth's crust consists of what? Of ionic compounds. So we will read the definition later. Now, a familiar example of an ionically bonded compound is sodium chloride, which is the table salt, NaCl. Now, how can we find it in Earth? We find it in rock salt. Do you see here? Now, so you have Na plus and you have what? Cl minus. Now, there is an electrical force of attraction between oppositely charged ions. And we said this before when we took a video about the ionic bonding and when we read about ionic bonding. Now, those ions combine in a 1-to-1 ratio so that each positive charge is balanced by a negative charge. Okay? So what is an ionic compound? Is composed of positive and negative ions that are combined so that the numbers of positive and negative charges are equal. Okay, it means the sum of the charge of NaCl is 0. Okay, so this is an ionic compound. Okay. Now, most ionic compounds exist as crystalline solids. Okay, we will see figure 3.1. Now, a crystal of any ionic compound is a three-dimensional network of positive and negative ions mutually attracted to one another. As a result, in contrast to a molecular compound, an ionic compound is not composed of independent neutral units that can be isolated and examined. The chemical formula of an ionic compound merely represents the simplest ratio of the compound's combined ions that gives electrical neutrality. Okay, so please focus now. So we will see figure 3.1 and we will see the crystals. So you see here, these are crystals. You see, sodium chloride, common table salt, is an ionic compound. You see, these are crystals, three-dimensional network. Okay, so this is now an ionic compound. Now we understand what's the meaning of ionic compound. So let's continue. Now, the chemical formula of an ionic compound shows the ratio of the ions present in a sample of any size. So when I say a formula unit is what? Is the simplest collection of atoms from which an ionic compound's formula can be written. So the simplest formula, when I say a formula unit, for example here, formula unit of NaCl here, of sodium chloride, what is it? It is NaCl, the simplest collection. One atom from Na and one atom from Cl, you see, or actually one ion, Na plus with one ion, Cl minus, they combine each other, okay, so they become NaCl. This is the formula unit, the simplest collection of atoms. Now, in the naming of monoatomic anion, the ending of the element's name becomes IDE. I told you about that. So the naming of the positive ion, the cation, it stays the same. We say sodium. But for the negative ion, the anion, Cl minus, it is what? Chlorine. We change the ending. We change it to IDE. So it becomes chloride. So the whole name becomes sodium chloride. Now, the ratio of ions in a formula unit depends on the charges of ions combined. It depends on the charges. So, for example, you have calcium fluoride. Now, what is the charge of calcium? It is the positive ion. It is 2 plus. But you know, for fluorine, or fluoride, it is -1. So how? So the calcium will bond with what? With 2 fluorine atoms. You see here? So it will become calcium fluoride, CaF2. You see here? CaF2. Now, please focus on this. So let's continue. Now, the main idea here is what? Ionic bonds form from attractions between positive and negative ions. We took this. So in ionic bonding, there is what? Attraction. Okay, because the transfer of electrons happened, so you will have a positive and a negative ions, so there will be an attraction. It is similar to a magnet. Okay, it is similar to a magnet. They will attract to each other. Okay, now, so for example, you have here a sodium atom and you have here a chlorine atom. This is a neutral. Okay, sodium. Okay, remember the dot, the Lewis structure. Okay, the dot here. Okay, remember. So we only draw the valence electrons, the electrons in the outer shell. And here also for chlorine. Okay, it is 7 electrons. This is 7 valence electrons, the electrons in the outer shell, or we call it the valence shell. Now, we have already seen that atoms of sodium and the other alkali metals readily lose 1 electron to form cations. Now, remember, the metals, they lose. The non-metals, they gain. Okay, you see here, they gain. You should remember, we took that. So, in a reaction, you see what will happen, the combination in a reaction. Then A will lose. So, it will become an A plus. And the Cl, the chlorine, it will gain. So you see from chlorine it becomes chloride anion. Now, the transfer of an electron from the sodium atom to the chlorine atom transforms each atom into an ion. Okay, and because now they are anions, they get attracted to each other and they become an ACl. Now, in the combination of calcium with fluorine, 2 fluorine atoms are needed to accept the 2 valence electrons given up by 1 calcium atom. You see here, Ca, it has 2. But fluorine, it only gains 1. It needs 1 to have a full octet. So what will happen? The calcium will bond with 2 fluorine atoms. So you will have a Ca2 plus, and you see F here, you see here, F minus, okay, fluoride, okay, fluoride anions. Okay, you will have a fluoride anions. Okay, so the calcium will lose 2 electrons, 1 to each fluorine, and each fluorine gains 1. Okay, so remember that, it is very important. So let's continue now. The characteristics of ionic bonding. Okay, now recall that nature favors arrangements in which potential energy is minimized. Okay, so that's why these bonds happen, because now they want to become stable. The elements, they want to become stable. What's the meaning of stable? Their energy becomes less. So you see here, the nature favors arrangements in which potential energy is minimized. It means nature favors reactions that will decrease the energy, then they become more stable. Now, in an ionic crystal, ions minimize their potential energy by combining in an orderly arrangement known as crystal lattice. So we took before what is a crystal. It's a 3D dimension. Okay, so a crystal lattice, okay, you will see it is like this one. You see, as you see here, okay, this is called what? A crystal lattice. 2 models of the crystal structure of sodium chloride are shown. It could be here or it could be like this. This is a 3D, okay, dimensional. You see here, it shows, okay, the bonds and what this, they become, now the ions, they minimize their potential energy by combining in this way. Okay, in this arrangement, in this orderly, this order, everything is in order. Now, the attractive forces at work within an ionic crystal include those between oppositely charged ions and those between the nuclei and electrons of adjacent ions. The repulsive forces include those between like charged ions and those between electrons of adjacent ions. Now, the distances between ions and their arrangement in a crystal represent a balance among all these forces. Okay, so I hope you have understood this lesson. This is the end of our lesson.